Now let's start this question. Climbing stairs. You can climbing a staircase. It takes any step to reach the top. Each time you can either climb one or two steps. In how many distinct ways can you climb to the top? So now you can see example one. Here's example two. Now you can see the explanation. So one step plus one step equal to two, right? So that's why here. So we count one time, or you can count one ways. Here we can directly take a climb two step, right? So now we have two ways to reach the top, reach the end, right? Now you can see here so many company ask this question, so I think you need to prepare this question. Now let's start this question. So net n, it may start from 0. If we n is equal to 0, which means we need to return 1. If n equal to 1, so we know each time we just only two choice, right? One step or two step. But if we choose the two will over the one, right? So we cannot use this way. So we only one step to reach the end, right? Here. So that's why here say 1. Now, how to get the 2? So we can use we can make a decision tree, which means, so yeah, I show you the diagram. So here you can see the question say climb one or two step. So now here we can take one step. So now become 1. If we take two step, here become 2, right? Now we know here we already reached the top, right? Or I would say reaching the end, right? So which means we cannot just go further. Here we cannot go further. So if we try to go further, so not, for example, here 1, 2 plus 1 equal to 3, right? And here go to 2 plus 2 equal to 4, right? Now it's over the 2, right? So that's why we cannot keep going down here. So if we got a 2, we cannot keep going down. So we only here. Now, here had two choice, right? We go climb one step or two step. It will, here will become 2, right? Okay, now we got, it's one way, right? Now, if we hear 1 plus 2, we got a 3. Okay, this is not correct. This path is not correct. So now, we can count, it's 2, right? Okay, now we can say n equal to 2. Oh, 1 second, let me remove this one. Now we say the result is 2. Now, if n equals to 3, what is the, how many way we have? Let's see. We're doing the same thing. We're just doing the same thing here. We have climb one step or two step, right? So now the current is 1, and here is 2, and then we still do the same way, 1 over 2. Now here become 2, here become 3. Okay, now we got the one way, right? So here we cannot move forward. We cannot keep going down. Now only here, okay, 1 and 2, because we had two choice, right? Now here become 3. Okay, now we get one more ways. Now here become 4. Okay, now it's dead end, right? We cannot keep moving down. Now here, go back to here, also do the same thing, 1 and 2. And here can become 3. Here can become 4. Okay, now it's dead end, right? We cannot keep moving down. Now, one way, two way, and the three way, right? So I would say three way, reaching the end, reaching the 3, right? Now if we can I can show you now one more example for how many way we can climb to the top. Now let's quickly go through this one. So that's why you just make a decision tree. You can easier to understand this question and understand the logic behind the scene. Now here 0. We always start from 0. Then we have two choice, 1 and 2. Now here become 1, here become 2, and here here 1 and 2. So now 2 and 3. Right now here is 3 and 4. Okay, now we're reaching the top, right? We're reaching the end. So now we cannot move forward anymore. So here is 1 and 2. So now it become 4 and 5. Okay, because 5 is greater than n, because the current n is 4. So his dead end. We cannot keep moving down. So now it's second way because here's 4, right? You can understand we can use this way to get all the possible permutation. And then here also two way, right? 1 and a 2, and then here 4, and then here 5. 5 is dead end. So now we got a third. So we just use this way. So finally, because I don't have enough space here, so I would say the final we will get 5, because here still have 2 way from here. Now, so now you can get the formula, right? If the n equal to 2, okay, we just add a period sum, period step, and then we will get a 2, right? And now if n equal to 3, okay, we just add a period 2 sum, and then we got a 3, right? We just sum up these two value. So we got a 3. If n equal to 4, okay, we just sum up previous number, so we got a 5. So you just use this way to get the final solution, final result. Now let's code it up. So if n equal to 1, okay, we'll return 1. Now here we need to do that. It's dynamic programming, right? So we need to n plus 1, and finally we need to return n. Now if here index equal to 0, which means 1. If index 1 equal to 1, so now we can start from 2. Right, and I equal to I minus 2 plus I minus 1. Okay, you can see pass on the test case. Now let me submit it. Okay, 100%. The time complexity is O B of n, right? Because it's just n, right? We just reaching the n, we start the go through the array. The space complexity is also B of n because we create an n space to store each element. Now, thank you for watching this video.